Hi everyone, my name is Ashley,
My name is Allison.
and for our Chem 160 presentation, our focus is on Invokana, which is also known as Canagliflozin. So for our mode of action, Invokana is a oral diabetes medication that helps control blood sugar levels. It works by helping the kidneys get rid of glucose from the bloodstream. It also lowers the risk of end-stage kidney disease and those with heart kidney problems caused by type 2 diabetes. So on the right there, it shows the structure of our compound. In a more technical sense, Invokana is known as a SGLT2 inhibitor, which is also known as a sodium glucose cotransporter 2 inhibitor. This is a class of medicine used to lower high glucose levels for those with type 2 diabetes. They are located in the renal tubules of the kidneys, which are responsible for reabsorbing glucose back into the blood. As a result, more glucose is excreted into the urine. Additionally, the drug increases sodium delivery by blocking SGLT2 cotransporters.
And this is the retrosynthesis found from reaxes, and we'll start from our drug of interest and work backwards. So the first step that we found was from syntheses of SGLT2 inhibitors by nickel and palladium catalyzed Fukuyama coupling reactions. And in this step, 4 would react with trimethylsilyl iodine in DCM for 8 hours in a temperature of 0 to 20 degrees Celsius in an inert atmosphere to yield our compound of interest, Invokana, with a 92% yield. And to get compound number 4, this is from process for the preparation of SGLT inhibitor compounds. You would react 3 in a reducing agent and boron trifluoride diethyl etherate in solvent, and after purifying the crude compound for that, the purification led to our compound number 4 with a 95% yield. And to get compound number 3, from the same resource, you would react compound number 1, which is 2,3,4,6 tetra-O-benzyl D-glucopyranose with 2, and a sodium hypochlorite solution, strong base, and organic solvent at a low temperature of negative 80 to 0 degrees Celsius to yield 3 with a 70.2% yield. Now this is the forward synthesis of our drug, Invokana or Canagliflozin, and we chose to explore the discovery synthesis reaction scheme. And this scheme was discovered by Mitsubishi Tanabe Pharma, and it was promoted and marketed by Janssen.
So for the first step, compounds 6 and 7, as seen on screen, are coupled under a Friedel-Crafts reaction to form a ketone or compound 8. The mechanism is as follows. The acyl chloride group from compound 7 reacts with aluminum chloride, forming a bond between the two. This reaction is a Friedel-Crafts, so the chloride group kicks off, leaving a carbanion. The lone pair then reacts with the carbon next to the sulfur group, which then shifts the double bond up, creating a cation. The hydrogen then reforms the double bond, creating stability, which finally produces compound 8. The second step involves a reduction of compound 8 to form an aryl bromide or compound 9. Compound 8 is reacted with boron trifluoride esterate, which breaks apart and reacts with the carbonyl group, and boron trifluoride attaches itself to compound 8. The electronegative oxygen is nucleophilic and then reacts with trimethylsilane twice, as seen on screen. boron trifluoride reacts with diethyl ether to reform the starting material. Finally, water breaks apart the compound, producing compound 9.
The next step in this reaction scheme involves compound number 9 being lithiated by N-butyl lithium in THF and toluene at negative 78 degrees Celsius. And once that occurs, the new compound is then coupled with peroxylgluconolactone and compound number 10. And after that is treated with acidic methanol, O-methyl glycoside, or compound number 11, is produced. The last step in this reaction scheme involves compound number 11 being reduced to form Invokana, or our drug of interest. The mechanism for this reaction is as follows. So the lone pairs on the oxygen of the methoxy group right here would attack the hydrogen on the triethylsilane, which would then yield a positively charged oxygen atom right here, and then the boron trifluoride esterate boron oxygen bond would then break apart to form two radicals, and the lone pair on the boron atom would then attack the tertiary carbon right here, and the methanol will be kicked off. This will yield this compound right over here, and then the diethyl ether and boron trifluoride would then react again to form the boron trifluoride esterate, and the resulting compound will be Invokana, or our drug of interest. Thank you so much for listening to our presentation.